coming up, we're going to be talking about salt, which was written by a guy who hosted his presentation, but he had some fairly drastic changes to a job situation just a couple of weeks ago. So he's in LA, couldn't be tonight. Since I've seen his presentation twice, I thought I'd give it. His original presentation is available online and probably worth a look. Because sometimes it helps to have everything explained in more than one way. But we will have him back. His name is Thomas Hatch, and we will have him back to talk about other parts of salt or layers above salt sometime in the near future, because it's a really exciting project. He's aiming high, and there's a lot to talk about. So,
sorry, didn't have the audio on. Okay.
So before I get into it, does anybody have any questions? Is anybody already familiar with salt and have questions, or is looking to learn anything specific, or should I just get into it?
Let her rip.
So, salt is many things, and it will be many more things. I think a great way to describe what salt is a really efficient communication layer. It's got some tools. It's got some tools that are bundled with it that use that communication layer. But one of the very cool things about salt, and the reason that it's so useful for building on top of, is this really efficient communication layer to talk to a bunch of servers all at the same time. Thomas Hatch was originally started a project to write a tool that could provision cloud servers automatically. And as he was getting into it, he realized that a lot of the things he was writing could be abstracted out into this kind of general purpose communication thing. And so that's when he started Salt, as this actual refactor of that functionality, or that extraction of that functionality. The project that does that cloud server provisioning is another tool on top of Salt called Butter. So that's one of the things that hopefully Thomas will come back and present on himself. Yep. So, getting started, the functionality that ships with Salt, one of the bits of functionality that ships with Salt is it's a remote execution manager. So, if you've ever used something like mCollective or Func, and I haven't used either of those, so I can't really talk about them all that much, or in the Python world, there's something called Fabric, or in the Ruby world, it's called Capistrano. And these are tools that run arbitrary commands or predefined commands on remote hosts. So, like in the example of Fabric, you would use it to say deploy code to a server. And you would have all of the functionality to deploy that code in a Fabric function that you would run. You would use it to run, aptitude install, whatever, on a bunch of servers, or really just any kind of arbitrary shell command. So one of the reasons Salt is so exciting is it's very, very simple. It's got a very pluggable architecture. You can customize almost every layer of it, and it's just simple. like some of the other things that we'll get more into this, but some of the other things that SALT is intended to do is you've got remote execution, you've got state enforcement like Puppet or Chef, and the state enforcement it's still in its infancy, but it's coming along. It's something that Thomas is really excited about, so it's definitely moving quickly. All of SALT is moving quickly. And so these other systems like Fabric or Chef, they're fine systems. I don't want to badmouth them. They do really important work, but they're very difficult to get up and running with. They're complicated systems, whereas SALT is very simple. So SALT is a Python library, is a Python module. Package. So to get started with SALT, you have to install its dependencies. One of which is ZeroMQ. Is everybody familiar with ZeroMQ, or anybody want a quick overview? ZeroMQ is it's a networking library that gives you concurrency. The interface when you're interacting. So ZeroMQ has language bindings for, I mean, pretty much any language you can think of, or maybe I should say any language you would want to use. And what it does is it presents an API which is like a socket API to do concurrent networking. So the interface is real simple, and ZeroMQ is the new hotness. Everybody's really excited about it. It's really fast. So SALT uses ZeroMQ for most or maybe all of its networking. So some of the other dependencies besides ZeroMQ are a couple of Python crypto libraries, and it uses Cython. One dependency is GCC. Cython is a way to write Python programs that compile down to C. So one of the things on the short list for this project is to get OS level packages for SALT. At the moment, packages only exist for Arch Linux, but there are instructions on how to get up and running with SALT on, say, Debian, for example, in the documentation, and packages are forthcoming. So once you've got those dependencies out of the way, you just install SALT the same way you would any other Python package. Easy install will work just fine. This is how you do it. If you're on a Debian system, you have to pass an extra flag to easy install. Check out the docs for specific instructions. But that's it. So let me show you what that looks like. Okay, so say like we've got a server here that we just installed SALT on. This is going to be a minion system. SALT has the concept of a master and many minions. So we've got SALT installed on our minion here. We want to start up. We just installed SALT. We want to start up the minion. First, we have to edit the minion configuration file. By default, SALT will install a configuration file for minion and master. To get up and running, you only have to edit one line in the minion file, and that that line is to appoint the minion at the master, and that's it. So we'll go through some of these configuration options in just a second, but so that's done. We've configured our configuration file. So we start up the minion. Oh, ignore that. Where was I? Yeah. All right, let's try that one more time. So you can see before it was complaining that the public key was rejected. That's because I just created a new public key for this host, and my master already knew about it. So I removed the public key from my master. My master's already running, and I started this. So as you can see, it's pulling the master. After you start up the minion, you have to accept the key. So as you can see here, this is a list of all of the keys that are currently available, that the master currently knows about, the unaccepted and accepted. So we can accept that key individually, or we can accept all keys with -A. The help for this tool is very informative. So that's it. It doesn't matter what order you start the master or the minion in. That's kind of a thing that ZeroMQ does. It'll just wait. It'll just wait until the master becomes available, like it has here. So you can see it stopped pulling. So I'm going to kill. I'm going to kill this this daemon, and I'm going to restart, or this. Yeah. I'm going to kill this minion, and I'm going to restart the minion as a daemon. So you can see it's in the background now. The Salt Master has the same option. You can start it as a daemon. Yep. So Salt uses AES encryption, and it uses public keys. To handle that encryption. There's a lot of options here in the config file that you can go through. The master is the only one that's required in the minion, as I said. And this whole file is very well documented, so I'm not going to go through the whole thing. It's really easy to read. Anyway, it's highly configurable. Another thing to point out is you can put your own configuration options in this file. This is a YAML file. So you can put your own configuration options in here, and then when you go to, say, write your own extensions to Salt, you can pull in those configuration options, or those configuration options are already available. I'll mention that again. Let's see. Yeah, the keys are stored in etc Salt. So are the configuration files. Let's see. Yeah, you can read all that on your own. So you can see that there's the Salt program itself. There's the Salt Master and the Salt Minion. You start the master up on one server, you start the minions up on a bunch of servers, and then you use Salt, the Salt command, to interact with the minions from the master. There's also Salt Key, as you saw, to manage accepting those public keys, and Salt Copy. Salt Copy is kind of like the copy command. It's intended to copy files from the master to the minions. I can show you that real quick, just because it's interesting, I guess.
How much faster is that compared to, because it's using ZeroMQ? Is that any faster? Because it's using 0Q, or is it just SCP?
It's not SCP. No, it's not using SSH at all. It's just using the communication interface that Salt is set up with 0MQ and its own AES encryption. He's asking if it was faster, if doing this command was faster at copying a file over 0MQ than, say, secure copy. I don't know the answer to that yet. I guess I can speculate. I don't know the answer. So what we have here is I've just got some file called soc.py. It's a SALT module, and I'll talk about modules in a minute. So this is just copying a module that I've got locally here on the master to all of the minions. And as you can see, it's pretty fast. There's what, 5 hosts here? Yep. I apologize, I don't actually know what salt call is. Alright, so we're up and running. We've got a master, we've got the master talking to minions. So how do we actually use the minions? You have to, so you use the salt command, and you have to specify a target, and then you have to specify what you want to run on the target. So in this example, we're just using regular shell-style globbing. So when the minions, the minions identify themselves to the master. The default is their host name. You can configure that in the minion configuration file. But by default, it's just the host name. So you can see here that we're just running a test.ping command, which I'll show you in a moment, on host.star. You can also specify -E to use proper regex. So like you just want hosts 1 through 3. You can do -L to do a list of hosts.
-E is the standard POSIX regex then?
Yeah. CRE, let's see. Yeah. Oop, thanks. Or you can use -G, which is which calls the grains system that's built into Salt. So with a lot of remote execution offerings, they kind of restrict you to they're kind of restrictive as to what hosts you can specify. And Salt is intending to be very, very flexible on that front. So as you can see, you can do what most remote execution offerings will give you, which is host name or the name of the system. But with Grains, when a minion starts up, it collects various information about the system that it's running on. All of the information that's available in the Grains system is static information. So information that's not going to change while the server is up, essentially. So the operating system, the kernel, that sort of thing. In order to see what all information is available on your hosts. By the way, I'm going to show you the test.ping command real quick. This is not an ICMP ping. This is just a salt ping, yeah, saying that this host is up. So to see all of the grains information that's available, you do grains.items. And as you can see here, what do we have available? We've got CPU architecture, domain, host, kernel release, operating system, and the path. Virtual. At the moment, don't quote me, but these machines that I'm running on are virtual machines. And as you can see there, one of the things it'll pick up is whether or not it's a real machine or a virtual. I kind of remember Thomas saying something about only KVM machines were supported at the moment. These ones are.
KVM and Zen.
Oh, is that right? And these virtual machines are VMware. Thank you.
So it says virtual colon physical, what does the physical mean?
That's a dictionary. So the key of the dictionary is virtual. So it'll be either virtual or virtual physical.
Oh, okay, so they're all actual boxes.
Yeah. No, yeah.
I don't see a
It
virtual.
thinks it is anyway.
It thinks it is anyway.
Oh, so you're running a virtual one that it thinks is a bot?
Yeah.
How do you manage that?
Yeah. It only support. It doesn't support VMware
Oh,
at the moment yet.
Detection.
Just show that. Grains.items. You can also specify multiple commands to run all at the same time, and the benefit of this is the master doesn't issue the commands separately to the minions. It does it all in the same connection, so it goes a little faster. So you can see in this one, the 3 commands that we're running are comma delimited there at the top, and then the arguments to those commands are also comma delimited. So there's 3 commands and 3 arguments, so they match up like that. Coming to Salt, it's currently in Salt. It needs a little love still, but is -X, which you can see here. And what that is instead of specifying hosts, you specify a command, and based on the return code of that command, you then run another command. So you can say, give me all of the machines that are running Postgres, or give me all of the machines that are currently running Apache, and then do something based on that. Or maybe give me all of the machines that are not running Apache, whatever. Yep.
Nice.
Yeah, that. So I don't know for certain that this is the exact proper syntax, but this is just looking for whether or not the Z shell is installed, and if so, it's pinging the box.
So when you do that, you have to do -N's command return code?
No, no. I'm using command return code because it specifically returns the return code. I suspect you could use other modules that also return a proper return status, but don't quote me on that because I don't know for sure. Okay, so we've got specifying the targets that we want to run stuff on down. So now we actually have to run stuff. So Salt ships with quite a few modules. These modules are available as functions to run in Salt. And to see a complete list of all of the modules, you can go to the official documentation, or you can run this command here at the command line. And this will show you everything that's available on your minions. So let's do that now. And please pipe it through less. It is long. So let's see. You can see. Oh, it didn't tell me because I didn't go all the way down. All right, there we go. 600 lines, 660 lines. So you can see that salt is very well documented by default, even in this early state. All of these are salt modules. So like for example, this is the command module, and then in the command module you've got various functions that can be run, like exec code, to run arbitrary code in this case Ruby or Python or Perl, whatever you put in the string. Return code you saw before just returns the actual return code itself, the number. Command.run, just an arbitrary shell command. You can use pipes, which is not always the case in some of these kinds of tools. So let me show you what that looks like. Command.run. Who am I? So as you can see, it's running as the root user on all of these servers. So this goes on and on. The copy module to push files back and forth. SciTest is like the test module, but in Cython, written in Cython. Disk usage, file utilities for changing groups, changing ownership. This is a grains module to display information from the grains system itself. Hosts module. A lot of these deal with the Etsy hosts file. You can query, you can change things, you can set things. The networking module, dig, netstat, ping, traceroute. The service module to stop and start things like anything that would live in your Etsy init.d directory. So modules are real easy to write. So as you can see, I've written one called the sock module, and it's got some functions in there that I copied from an old shell script that we've been using for a while, and I made them into a salt module so that way I can run the shell script across all of our servers all at the same time. And it's just a tiny amount of work. I'll show you what some of that looks like here in just a minute. The state system, the state enforcement system, which is the functionality that's like Fabric or Chef. Status, CP.
State enforcement thing.
I'll get to that. I've got slides specifically about it.
Oh.
Status, CPU info, CPU stats, disk stats. Anyway.
What does it show in CPU info?
What was it? I didn't get that right, sorry. Oh, status.
Nice.
Prop.
Yeah. Okay. Curious if that showed mode
Yep. So quite a bit in there, and then modules are really easy to write. So you can see. Wait, where am I going? So modules are just Python files in this modules directory. If you want to put an additional directory, modules in an additional directory, you specify that in the config file. But let's just look at the test module, for example. You can see that this test.ping that I've been running over and over is just a quick one-liner. It just returns true. So if the minion is up and accepting requests, it'll return true.
Oh, did you write that one yourself?
No, that one came.
Okay.
But they're really, really simple. You can see that the modules have access to any options that are in the config file, the minion config file. Any questions?
Are you working on developing this too yourself?
I am. I haven't done a whole lot yet. I've written some documentation. That's about it. But we're phasing in Salt at my work. Thomas is using it at his work. And so the more familiar with it I get, the more active I'll be with the Salt project. I'm really excited about it, and I'll kind of explain why at the end. But the short version is Salt is so simple, and it's intending to replace so many tools that are not simple. That just really excited to see it succeed.
How many folks do you think it can manage?
Thanks for asking. So test-wise, Thomas has it running on somewhere in the ballpark of 100-something servers, and it runs as fast on those 100 servers as it does on these ones that I'm showing you now. Just these 5 that I'm showing you now. He thinks that it's probably likely to be able to scale up to thousands, even possibly hundreds of thousands, without really any trouble at all. So the way that it works, the way that the master communicates with the minions is through a PubSub a topology, publish subscribe. So the master sends out, publishes some command to all of the minions that are listening for anything that's published, and then it's done. Business is concluded. So the communication happens on 2 interfaces, and I'm simplifying a bit, but 2 interfaces. First, there's the publish and subscribe interfaces where the master just publishes what it wants and where the minions are listening. And then there's another interface which I believe does bidirectional communication, where the minions return information to the master. So that's where it's getting that output that you're seeing on the screen is from that second interface. So once a command is published, it's done, it's over with. And then when information comes back, it comes back to the master as displayed, but it doesn't need to. You can specify in a module or also at the Salt command line that you don't want the output to return back to the command line, and you do that through using a returner. Now at the moment, Salt just ships with one returner, which is a Redis returner. And what that says is instead of sending me back the output of the command, send it to this Redis server. Just log it to this Redis server, and this returner is like 10 lines of Python. It's crazy simple.
And that's what the client runs.
Yes. Yep. So the returner happens on the minion, so the minion communicates to wherever the returner says. Instead of with the master.
Whichever server happens to be the Redis it says to talk to.
Mm-hmm. Yeah, and this is really open-ended. This could be anything. This could be Redis. This could be MySQL. This could be Postgres. This could be log to a file. This could be use syslog to log to a remote syslog server. Anything that you can program. like I said, the Redis returner is 10 lines of Python, so really the sky's the limit here. Yep. Any questions about how master and minions communicate? That's one of the reasons Salt is so fast. Is it doesn't it can send that command to however many people are listening pretty much simultaneously, and it doesn't have to wait for that response.
So it's solving a complexity problem for you. Has it had any other benefits?
Solving a complexity problem in that is replacing more complicated tools, or do you mean that
you
it's?
don't have to think as hard.
Yeah, for sure. If anybody here's ever done any system administration where they've written a little for loop on the shell to run the same command on a bunch of servers, this
Is your for loop now?
exactly.
Has it given you any heartache, any trouble?
Yeah, it's a young project. It's under heavy development. It's not at 1.0 yet. I think Thomas has said that once it hits 1.0, then he'll really consider it ready for prime time and really start hitting up trying to get it widespread attention. The state system, for example, is brand new. In fact, let's talk about that. We'll get to it in a minute. Right now. So enforcing states. So if you're familiar with Puppet or Chef, it's a way to enforce a particular state on a server. So you want to have such and such a package installed. You want to make sure that such and such a package is installed. You want to make sure that such and such a service is running. You want to make sure that such and such a file is contains the expected information. So you've got some configuration file in /etc for Postgres or whatever, and you want to make sure that that file is contains exactly the configuration options that you want. And if somebody changes it, this enforcement system will change it right back. That's what Puppet and Chef do. They're just indispensable to system administrators because doing this by hand on so many servers is just not something that's possible. It just takes too much time. So so this is a way to guarantee certain things, the state of certain things on a collection of servers. So if you're familiar with Puppet or Chef, they both have really complicated configuration files. They're both written in kind of a domain-specific language that looks a lot like Ruby, or you can just use Ruby. So in order to get up and running with these, you kind of got to get accustomed to the file format. Probably helps if you know a little Ruby. Rather than reinvent yet another configuration format for Salt, Thomas has opted to have this the system where Salt just needs a particular data structure, and it doesn't really care where that data structure comes from. So in this example, this is a configuration file which is in YAML, and so you run this through something that'll parse YAML, generate the data structure that Salt needs, and Salt's happy. So what this means is the way you define these I don't know, in some of these configuration managers, they're called manifest files. So how you define these manifest files in Salt is you write what's called a renderer. You know, if Salt doesn't have the exact configuration format that you want or you're looking for, you just write a quick renderer, and again, it's just real simple. You just have to parse some file and return a data structure. So that means that you can have a renderer for pretty much any arbitrary language that you want. You can have YAML. You can generate YAML through some kind of templating language like Jinja in this case. You can write one in Python and return the data structure from you just build a data structure in Python and return that. You can write it in really anything. Sky's the limit. You can have XML, anything you want.
So you can put your configuration anywhere you want, so long as you got a renderer for whatever language that config's written in, and it spits out YAML on the other end.
No, it spits out a data structure. So the YAML generates some data structure that Salt can work with. So since renderers are written in Python, then data structure is ultimately in Python. So you can see in this case, this is a Jinja template, and you've got a little for loop in there that installs or that sets up the state for Apache and Postgres and makes sure that they're running. It makes sure that the package is required. So you run this through the renderer that can parse YAML through Jinja, and you get this data structure that Salt cares about. So the state system is pretty new. I think Thomas has it working pretty well now. I'm sorry to say I would have liked to have demoed it, but I haven't had a chance to play around with it yet. Also, the documentation on the state system is forthcoming, but the next release that Thomas plans on doing, I think will have the state system pretty much squared away, including documentation. So in the meantime, you'll have to do a little source diving. But yeah, any questions?
Okay, so the structure it needs is in Python. What is there anything specific about it? Is it a Python struct or?
Yeah, I can show you. Let's see, which one were we looking at? YAML Jinja. So basically, it's just this render method, which is what we're looking for. So there's not much to it. You're looking at 10 lines. So what it's doing is it's rendering the template and then running it through the YAML parser to return the data structure. So based on this hypothetical slide, or maybe this one would be a little bit easier to grok. You're looking at a data structure like a Python dictionary, or like a what is it called in other languages? Drawing a blank.
Ordered list.
Yeah. Thank you. A hash. So this would be the key. This would be yet another key. This would be a list. That sort of thing. So, like I said, Salt is under heavy development. It's got a lot already, and it's got a really good architecture in place. but it's got some rough edges, and it's certainly missing a lot of things. It's missing packaging. It's missing modules that would be, really useful to ship with Salt. Like, for example, the apt module was added to Salt fairly recently.
What does that do?
Sorry, yeah, thanks. The apt module is
Apt, okay.
yeah, for calling out to the apt suite of tools to install programs, to work with the Debian and Ubuntu package manager.
Tell all those to install something using apps.
Exactly. So these modules are really easy to write. I kind of mentioned that before, but let's take a look at the apt module, and I'll show you what I mean. So one interesting thing about modules is they can configure their own name based on the grain system. So for through this virtual function. So for example,
What's configuring insomnia?
I'll show you. All right, so we're looking at the apt module here, right?
Mm-hmm.
But there's no apt module listed here. In fact, it shows up as package. Let's see. Where am I? It's not there, and I don't know why. Yeah. Am I running an old version of Salt? Let's check. Let's see. I sure am. So I mentioned that the apt module was added recently. It is not in the latest official release of Salt.
Then
So-
I guess it wasn't added, huh?
Say again.
Then I guess it actually wasn't added. It's
Oh,
not in the latest release, right?
it.
Maybe in the dev release?
Yeah, it's in the development version. So okay, so so what this line is doing is instead of showing up as apt in the list of modules, it shows up as package. And what that lets you do is it lets you generically call the same function across different operating systems. So, for example, you run, Salt, your list of hosts, package dot install whatever package, and then the grains system takes care of calling out to Aptitude if it's on a Debian system, or calling out to Yum if it's on a Red Hat system, or calling out to Pacman if it's on an R system.
So it can actually arbitrate the install manager on the OS.
Yeah. And the way it does that is by dynamically renaming the actual module name.
Isn't that going to cause problems if they don't use the same kind of argument list in the same mode sequence? Or
So in theory, that sort of thing should be abstracted out in the individual modules.
so this module should take care of it.
Yeah.
So these other functions should kind of like alter it for Yum, alter it for whatever else that isn't tapped.
Yeah. I imagine that there is an ultimate limitation there somewhere. So, you know, if you've got wildly varying package names, you're probably going to run
Package manager suddenly changes its interface.
in that case, you probably just update the module or write a new module. And then use the grain system to figure out if you're on the version where it changed.
Oh, cool. Yeah.
So you can see here that you know, it's just shelling out to the apt-get command line tool and returning the result. So there's really not a lot to writing these modules, but Salt could certainly benefit from new ones or polishing up the existing ones a bit. So Salt is that communication framework that I talked about, and it's intended to be a stack, a suite of tools. And on that note, the official Salt webpage is saltstack.org. So it does remote execution. It does that very well right now. It works fine. It's fast. It's efficient. Configuration management is very nearly done, where you can again define what services are running, the state of certain files. Other things that are coming, monitoring, probably on a level somewhere above Salt. The idea being that Salt would be a good replacement for tools like Munin or Nagios, where it pulls on the server that the minion's running on. It pulls, you know, for the state of something. It checks to see if Apache is running. It checks to see if there's enough free disk space. And using the returner system that we talked about, where Salt minions can arbitrarily or can send data to arbitrary destinations, you would say, you know, this monitoring system should use this returner to log to you know, this database that the monitoring system is looking at. On that note, stats gathering. It probably should have done those in the reverse order. So Salt is gathering stats on a particular server. If suddenly it finds that it can't gather stats, or the stats that it's gathering are you know, above a certain threshold, then it would trigger you know, some kind of monitoring solution. It would, you know, page you at 3 a.m. in the morning, or possibly you know, if it was monitoring a virtual server, for example, you know, say the virtual machine suddenly goes down, this could start it back up automatically, that sort of thing. So monitoring and stats collection probably will go in a layer above Salt called Butter, which is what I'm hoping Thomas will come back and present on. And Butter will also do the cloud server integration. So it's a great start. It's crazy simple. It's really easy to work with. It's fast. It's efficient, and he's got this great framework. But there's still a ways to go. But it seems like all of the right pieces are in place to make that happen, and when it happens, and we're going to replace, you know, something like, you know, Chef or Puppet that take a week to set up, or, you know, Nagios or Munin that take another week to set up, with something this simple. that scales as well as it does, I think it's going to be a pretty fantastic day.
So, it's not doing any monitoring or stats yet?
It has Butter has some kind of monitoring in the works. There's been code written to that effect, but I haven't had a chance to play with Butter yet, so I don't know what's there and what's not. Hopefully, by the time Thomas comes back to present on us, present here for us, Butter will be in a state where that sort of thing is ready to demo. So I blew through that a little bit faster than I expected to. Any questions?
Can you show the app.py again?
Yeah. So you can see this particular module function available versions just calls out apt cache and show and processes that.
So, but this particular, with grains, I've noticed that it doesn't differentiate between the Ubuntu system and a Debian system. Is that
It does.
does?
Or at least it should be. Let's see. No?
No.
I thought for sure I saw
Although
that.
it could if it was.
Right. Right. See? Oh, it's Debian.
My mistake?
Now, also in the core, I also saw that there was a section written for VMware.
Mm-hmm.
Any plans on implementing that, or no, or?
That's, I apologize, that's a question for Thomas. Yes, he does want to expand the grain system to other virtual environments. I don't know where on the pipe that is. Any other questions? Anything anybody wants to see?
Well, you say it's good for cloud servers, just generic server management. Is there anything with this that you can't do or without it?
Like something that's specific to this tool that's not
Yeah.
in other tools?
Yeah.
Yes. So Salt was created because of deficiencies in some of these other similar tools. Like, for example, some of these remote execution tools are really restrictive on how you can specify which hosts you want to run commands on. So that was one of the design goals of Salt, to be really flexible in which hosts you can specify. Other ones are very slow. You know, I can speak from personal experience working with Fabric. It runs the command that you give it on each host in succession, as opposed to concurrently. So it's real slow, and obviously doesn't scale to any significant amount of servers at all. So Salt was intended to replace those and be able to run on, many machines efficiently. So Thomas has written tools like this for a couple of companies he's worked at previously. I think this is his third go. This time he's doing it the open source way. But you know, and he's learned a little bit with each iteration. So yeah, so Salt is definitely designed to be better at encountering deficiencies he's discovered with other tools.
Yeah, the host selection sort of struck me as rather similar to an SQL select.
Hmm.
Being able to pick and choose however you want your data set returned.
How does Salt behave with, you know, Salt Master is one version, Salt Minion is a version less?
So I've got very limited experience messing around with this, but I have been running the Salt Master on the latest version, and the Salt Minions on the next to latest versions, and I haven't run into any trouble. Obviously, the minions are missing some functionality that should otherwise be there, but since the minion is running a specific version with its specific, you know, with everything that comes with that version specific to it, and then communicating you know, through 0MQ, you've got I expect you've got a pretty good buffer there. I mean, I guess I don't know for sure,
If
but
you decided to run something that's in a more, like you demonstrated, a different version of Salt, where they haven't incorporated this, the Salt Minion will return.
yeah,
Some more data version, yeah.
exactly.
Stack trace.
That's
so-
what I don't want.
So like you saw in this instance, that the apt module is missing, so that module isn't available on the minions. So when you do that list of the sys.doc, by the way, I should have mentioned, since this list is so long, you can definitely drill down and say that you're only interested in the documentation from, say, the test module, or maybe you're just interested in the documentation for the test.ping function in the test module. So you can drill down the documentation that way. But so this sys.doc returns the full list of things that are available on the minion. So, you know, say like you've got one minion that's running one version of Salt and one minion that's running another version of Salt. If you specify the host in this, you know, the specific host that'll return the specific list, it's available on each. If you've got that kind of setup in your return, you know, and you specify your host list like this with a star, then you won't know which is coming from where. So I mean, there's some potential for trouble there, yeah.
Yeah, my point is so if you've got a developer who did this but didn't update on the minions, and you wrote a command and you assumed that all minions were running, and you specified the host name, what exactly is returned? Because I don't want to deal with some sort of stack trace.
So say like you've got different versions of a module installed on two different servers, and one of them has a particular function in that module, and one of them does not. But both of them have the module. It's just a different version of the module, for example. What you'll see then is the correct result from all of the minions that have that module and run it successfully. And then on the one that doesn't, you'll see just a Python error message. You'll see the error message in the result itself. So the minion will generate that return message, that error message, and send it back. That's in the case that it's missing. If you've got, I mean, I'm speculating here, but if you had two different versions of a module on two different servers, and And they both had the same function, but you know, did say wildly different things. Then, yeah. They would both do their separate things and then return the result, assuming that didn't cause an error. You wouldn't see one. Yeah. Any other questions?
What is salt?
Fortunately for you, we've made a recording.
Any plans on making something called pepper
We can only hope so.
and making butter? I know there's plans for ghee.
Yeah, ghee. Ghee is going to be a graphical user interface, a web interface to salt itself, and maybe butter as well. I'm not sure.
Well, ghee, I thought ghee was going to be, I don't know what Joseph's got planned for ghee. We probably shouldn't speculate. No one's seen it except Joseph.